Okay, so you know to follow me, right? So let's summarize what we did earlier on. So what is a mole then? There's a video here, we talked about it, but can you remember what a mole is? Yeah, so well it's basically a certain number of molecules or a certain number of atoms. In fact, the number of atoms and molecules was written here. We wrote it down somewhere. That's correct. So 6.02 times 10 to the 23 atoms, or 6.02 times 10 to the 23 molecules, is of whatever it is is a mole. Now, clearly, because some atoms and some molecules are going to be heavier than others, then a mole of one thing is going to be heavier than a mole of another thing. So, for example, carbon. Let's zoom in here. Just give an example here. Oops. Okay. So, for example, carbon has got a mass number. Dear. Carbon has got a mass number of 12. And then hydrogen has got a mass number of, well, let's not pick hydrogen. Let's pick something like iron. Iron has got a mass number of 56, I believe, and I think it's 23 atomic number. So yeah, so basically, a mole of carbon would be 6.02 times 10 to the 23 carbon. Times 10 to the 23 carbon atoms. A mole of iron would be 6 times 02 times 10 to the 23 iron atoms. The difference being is because the mass number of iron is much larger than the mass number of carbon. The mass of a mole of carbon would be lighter than the mass of a mole of iron. Yeah. Okay, and then what was it about that number? Why was that number chosen? 6.02 times 10 to the 23. Okay, so let's well, you're half that's I'll come back to that point actually. But first of all, let's summarize that a mole of of iron would weigh more than a mole of carbon because each atom has a larger mass. So if we had 6.02 times 10 to the 23 of each in each case, then the iron's going to weigh more because each atom weighs more. Does that make sense? Yeah. So so that's fine. Now the reason why I mean, that would be true no matter what this number was, right? That sentence would be true no matter what this number was. I could make a mole of atoms to be just 1,000 atoms. It'd be a bit easier to remember if it was that, rather than 6.02 times 10 to the 23. But the reason why they picked this number is because it just so happens that when you have that many of carbon atoms, the mass of that is 12 grams. And when you have that many iron atoms, the mass of it would be 56 grams. So you can always find out the moles, the mass of one mole, or otherwise known as the molar mass, by looking at the mass number. Okay, so let's just get down that point. So the molar mass can always be found out by looking at the mass number. Okay? Right. Now, there is one thing to be aware of when we say things like that, and that is that with the example I nearly gave, which was hydrogen, which has a mass number of 1, it wouldn't be correct to say a mole of hydrogen is 1 gram. even though it would be correct to say a mole of carbon is 12 grams, a mole of iron is 56 grams, a mole of hydrogen is not 1 gram. So why is that? No. If I said, what's the formula? Basically, it comes down to this question. What's the formula of carbon? The formula of carbon is just C. What's the formula of iron? It is Fe. What's the formula of hydrogen? It's not H, it's H2, right? So when I say 1 mole of carbon, I mean 6.02 times 10 to the 23 carbon atoms, because the formula of carbon is just C, and the same with iron, 6.02 times 10 to the 23 iron atoms. When I say 1 mole of hydrogen, I mean this. I mean this lot of this. So 6.02 times 10 to the 23 hydrogen molecules, right? Because that's just how hydrogen exists. Okay? Does that make sense? So that would mean that what would it mean? What would be the mole? What would be the mass of what would be the molar mass of hydrogen then? 2 grams, right? Yeah, exactly. So it's always important. It will never really catch you out. If I said something like, what's the molar mass of H2O, of water, you'll go, well, that's not a problem, and you'll know how to do that, because you'll just look at the periodic table, and you construct it. You know that water's got a formula, but when it comes to elements, that's when it'll trip you up. Okay. So just beware that some elements exist as molecules, just like some compounds exist as molecules, and some elements don't. Some elements exist as atoms, and so in those cases it's straightforward. But when it's not straightforward, we must double it. Usually you double it, because usually it's H2, O2, N2, whatever it is. But you must take that into account. It's not always that. You can have ozone. Ozone is O3. Yeah, anyway, don't want to go off on a tangent. So that's what we talked about, what a mole is, and this idea of the molar mass is, when I said, what is the molar mass, I said, let's just shrink that, it's massive. The molar mass is just the mass of 1 mole. The molar mass just means the mass of 1 mole. That's all it means, okay? So don't get too confused by this terminology. Molar mass just means the mass of what's the mass of 1 mole. If you know what the molar mass is, it is just that, okay? I'll stop the video there.